Welcome to exam race. This is the quantum mechanics and we are here for free electron theory of metal. In this we will see both the cases of the free theory of metal regarding the classical as well as the quantum case. We will see what is the postulates regarding the classical case, what is the postulate regarding the quantum case, and also we will see the question related to the classical as well as the quantum free electron theory. So we will see the quantum field theory of metal, and this theory is actually given by the Arnold Sommerfeld. So what this theory is all about? This theory is all about the extension of the classical Drude theory or classical Drude metal that is incorporating with your quantum mechanics. And this theory was introduced by the Sommerfeld in 1920s. Also, this theory talks about the significantly, we talk about it, this theory talks about the understanding of electrical and the thermal conductivity of metals. So if we see the key features of this Sommerfeld theory is actually explain the behavior of electrons. What kind of behavior? The behavior of electrons in the Fermi-Dirac statistics, in the energy quantization, in the electron nature of electron wave nature actually. So it has a different possible energies that can be explained and by these theories. Or actually you can also say that this theory is actually talk about the Fermi-Dirac statistics. As you know, the Drude model, which is talking about the treating of the electron, or sorry, it's talk about the electron as a treated as a classical particle. But Sommerfeld used the Fermi-Dirac statistics. Why he used the Fermi-Dirac statistics? He used Fermi-Dirac statistics is to describe the distribution of the electron in the energy state. That I already told you that it will tell you this theory will tell you the concept of the energy states, and these energy states concept is taken by the concept of or by the um, model of Fermi-Dirac. Okay, so they describe the distribution of electron in different energy states of electrons, and also we know that in this theory this will talk about the indistinguishable particles. Okay, and these indistinguishable particles is going to obey the Pauli's exclusion principle. Clear? So all in all, Sommerfeld theory is all about the your electron waves, electron energies. Also we will talk about the electrical conductivity in this. Okay, electrical conductivity, this is the important concept here in this Sommerfeld theory. Why? Because Sommerfeld model is all about the explanation of the electrical conductivity, and that electrical conductivity is going to be your on the Fermi surface, or the electrons, means the electron near the Fermi surface, and that electrons over that surface is going to contribute the conductivity, and this is going to be you can say this electron going to be you can say that it's a deep with the Fermi-Dirac sea, or means you can consider the Fermi-Dirac sea, and also unable to gain the energy and change their state, and due to this change in state they follow the Pauli exclusion principle. Okay, also it will talk about the heat capacity. As you know, we have seen the model is talking about this kind of means Sommerfeld model is talk about the heat capacity. The model also provide the more accurate explanation of the electronic configurations or electronic contribution to the heat capacity of metal. For example, if I say at the low temperature, okay, what happened to the low temperature? Low temperature, metal heat capacity is proportional to temperature. Okay, so you can say heat capacity proportional to temperature. Okay, and this temperature concept is given by the Sommerfeld theory. Clear? So it also tell about the heat capacity and the nature of heat capacity with respect to the temperature, which matches the experimental observation that is we have seen in the classical models. Okay, also and talk about the thermal conductivity, as it already talk about the electrical conductivity. So if it is talking about the heat capacity, it means it is talking about the thermal conductivity also. Okay, so this thermal conductivity, or we can say the Sommerfeld theory, is explained the your you know Weidmann. Actually, this one is Weidmann French law. Okay, Weidmann French law is explained by this. This is Weidmann French law. And what is this Weidmann French law and how it relate with the Sommerfeld theory? So actually, the Sommerfeld theory explains this Weidmann French law, and which relates the thermal conductivity of metal to the electrical conductivity. This is a simple thing. Okay, but this simple thing is much more explained in the theory of the Sommerfeld. So this implies that the same free electron are responsible for both the phenomena. Means we are talking about the electron that is going to be explain the phenomena of electrical conductivity as well as your thermal conductivity. Okay, but it has certain impact, certain limitation, and before that limitations and impact, we must know what Sommerfeld take the assumptions. So according to the Sommerfeld theory, there are some assumptions that the free electron should be quantized. Okay, quantized, the simple thing, if I say Q equals to NE, and where N is your numbers, integers, you can say 1, 2, 3. So it should be quantized. It follows the Pauli's exclusion principle, because I already told you that is talking about the Fermi-Dirac principle also. So to follow that, we have to follow the Pauli exclusion principle. Also, when we it talk about that when electron is traveling, it has certain defined boundaries. Okay, it cannot go to infinite. So what kind of defined boundary? It means it is talking about the constant potential. Okay, potential should be constant. Potential cannot be infinite. And the last assumption was this, that all kind of negative, all kind of you can say attractive or repulsive forces, or positive or negative forces, are going to be neglected here. So these are the assumptions before we study the Sommerfeld theory. So as we see the theory that is related with the electron, or you can say free electron theory, it has certain postulate. What kind of postulates we are talking about? So our first